download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support and so much more. This video is about Group 7 elements. Now Group 7 elements are called halogens, and the Group 7 elements are fluorine, chlorine, bromine, iodine and astenine. Now fluorine is a very reactive poisonous yellow gas, so very reactive, and it's a poisonous gas. Chlorine is actually also a gas, and it's fairly reactive, not as reactive as fluorine, but it's also a poisonous green gas. Again, fairly reactive. Bromine is actually a liquid. It's quite a dense liquid, but it's quite volatile. And it's sort of reddy brown. And iodine is actually a solid. And it's dark grey in its solid form, but in its sort of vapour form, it's actually a purple vapour. So it's a dark grey solid, but as a vapour, it's purple. It's very important to note that they all exist in pairs. So fluorine, you'd see it as F2, chlorine, Cl2, bromine, Br2, iodine, I2. So always in pairs. Remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers and so much more. The link is in the description. Now, just like with the Group 1 elements, there are trends as you go down the group, and you do need to learn these trends. Okay, so as I write the elements here, we'll start talking about the trends. So as you go down the group, so again I'll draw an arrow to go down, they have a higher melting and boiling point. Okay, so it increases as you go down the group, which means that iodine has a much higher boiling point than fluorine. Again, just like with Group 1, as you go down the group, they have a higher relative atomic mass. Okay, so a larger atomic mass as you go down the group. Okay, the mass of fluorine is 19, chlorine is 35.5, bromine 18, and so on. These can be found on your periodic table. So as you go down the group, that mass gets larger. And finally, we have to talk about the reactivity. And these actually become less reactive as you go down the group. So they're less reactive as you go down. Now that's the opposite to Group 1. You'll remember get more reactive as you go down. But Group 7 get less reactive as you go down, which means fluorine at the top is the most reactive. And astenine at the bottom is the least reactive. Now again, that can be explained by drawing their electronic configuration. So fluorine has 9 electrons, so it has 2 and then 7. Whereas chlorine has 17, so it has 2, 8 and then 7. And hopefully what you notice here is that they both have 7 electrons and the outer shell. Just like in Group 1, they have 1 electron in the outer shell. Group 7, they all have 7 electrons in their outer shell. Now remember that the electrons are negative and the nucleus is positive. Now again, just like with every atom, they want to gain a full outer shell, and Group 7 elements are going to do this by attracting another electron to join them. Now when you look at it, the outer shell of fluorine, which is here, so this is fluorine, is closer to the positive attraction of the nucleus. So as that tries to pull in an electron, it's closer to the nucleus. So that positive pull is quite strong. That positive attraction is strong. Let's go over to chlorine, and again it will try to pull in an electron on its outer shell. However, it is further away from the nucleus, which means that a positive attraction from the nucleus is weaker, which means it's actually harder to pull in that electron, which makes it less reactive. And as you go down the group, that outer shell becomes further and further away from the nucleus, meaning it gets weaker and weaker. That positive attraction from the nucleus gets weaker. So it becomes harder to pull in an electron, and that's why they get more reactive, so less reactive as you go down the group. So we need to remember, as you go down the group, the melting and boiling point increases. As you go down the group, the atomic mass increases. And as you go down the group, they get less reactive. Now you can see how reactive elements are, specifically group 7 elements, by something called a displacement reaction. Now a displacement reaction is a reaction where a more reactive element will displace a less reactive element. So let's go through an example. So for example, we have chlorine and we have sodium iodide. Okay, now chlorine is group 7 and iodine is group 7. So to work out whether or not chlorine will take the place of iodine, what we need to do is we need to look at our periodic table, which I'm drawing out for you here, and you need to remember as you go down the group, they become less reactive. So we need to look, chlorine is here, and iodine is here. Therefore, chlorine is actually more reactive than iodine because it's further up the group. So that means chlorine will take the place of that iodine. So we're going to get sodium chloride, and iodine is then going to be left. And that is a displacement reaction where the more reactive element is taking the place of the less reactive one. Let's do another one. So we've got chlorine again, this time plus potassium fluoride. Okay, so chlorine is here and fluorine is here. So in this case, fluorine is actually more reactive, and therefore chlorine will not take the place of fluorine, so it will stay the same. Chlorine plus potassium fluoride will stay as chlorine plus potassium fluoride. Let's do one more. Okay, so we're going to have fluorine plus potassium chloride. Okay, so again we need to look at our periodic table. Fluorine, which is here, is higher than chlorine, which is here. Therefore it will take the place as it's more reactive. So this will go to potassium fluoride plus chlorine. So now what I want you to do is have a go at these questions here. So if you pause the video, and we'll go through the answers after. So pause the video now. So question 1, what is a displacement reaction? Well, a displacement reaction is when an element, or we should actually say a more reactive element, takes the place of a less reactive element. And when we talk about take the place of, we're talking about displace. So when a more reactive element takes the place or displaces a less reactive element. Number 2, what happens to the reactivity as you go down the group? It decreases. They get less reactive as you go down the group. What happens to the boiling point as you go down group 7? Well, it increases. They have a higher boiling point as you go down the group. True or false? All halogens are gases. Well, if you go back to that first slide, bromine is a liquid and iodine is actually a grey solid. So this is actually false. And finally, will fluorine displace chlorine from potassium chloride? So will fluorine displace chlorine from potassium chloride? Well, if we look at our periodic table, fluorine is higher, therefore it's more reactive. So yes, it will take the place. So it'll be potassium fluoride plus chlorine. So yes, it will. So there we've learnt about group 7 elements and their trends as you go down the group, and also about displacement reactions. If you have a go at working through the quiz and the exam questions on these now, that can really help you out. And if there's anything you didn't quite understand in this video, then please get into contact with one of our tutors who will be happy to help.